Bonjour à tous, I'm Cheryl Abundo. I'm a data scientist with Solvay based in Singapore. Donc, we would need to take a break from French. Désolé. I'm with the Solvay Business Services, and part of our role is to help business units to carry out data science and AI projects. So for this particular topic, we partnered with the electricity business of Solvay, from which Hubert belongs.
And good morning, I'm Hubert Sizaret. I'm a dispatcher in the electricity business of Solvay. And today we are going to talk to you about our use case. So we talked a little bit about energy this morning already with the gas demand, but we are going to focus on another commodity, which is electricity. And we'll talk to you about how we do to forecast both the production and the consumption. And so our mission today with Cheryl is to explain to you why we need to do that in a chemical company and how we leverage data science to succeed. So first, a few words about Solvay. Solvay was founded 150 years ago. We are really a worldwide company with 25,000 employees spread across 61 countries. And today we are focused on advanced material and specialty chemicals. So what do we do as a chemical company? Basically, we operate industrial process to synthesize chemical products. And you have to understand that this process and these products, they have a footprint on their environment. That's why I'm going to talk to you about another hot topic, which is sustainable development. Here you have our 5 sustainable commitments by 2025. And 2 of them are really typical for a chemical company. One of them is related to products. So we want to have more sustainable solutions because these products, they have a footprint on the environment during their whole life cycle. And I think chemistry is really powerful for this, has really a great potential to improve things. But today, I'm not going to talk to you about it. I'm going to talk to you about our target to reduce greenhouse gas emissions by 1 million tons per year by 2025. So how do we get there? First, we have a lot of projects going on all over the world on our industrial sites, but also on a project where we invest to build more renewable sources of energy. But I'm not going to talk to you about that either. I'm going to talk to you about Solvay Energy Services and what we do on the topic. So Solvay Energy Services, it has been created 15 years ago when the electricity and gas market got liberalized. And Solvay was such a big consumer of energy in France, it still is actually, that it made sense to have its own team to manage the energy supply. So we started to do that, and once we handled this activity, we looked at other things that we could do, and we started to go directly to producers to purchase their electricity. So hydro producers, wind producers, and PV. And we also open to other third parties. It means that now we are purchasing electricity directly from power producers, and we supply Solvay sites, but also other clients, industrial, tertiary, and even other suppliers that will target households. So how do we operate this business? So you have producers on the left and consumers on the right. Producers, they are producing, consumers, they are consuming. Okay. Of course, you know that electricity is not any commodity. You can't take a truck, go to producer, take your electricity, and bring it to point B. You need a grid in between. So we have a grid. It's the French grid, and we have system operators. They are called RTE and Enedis in France. Something very specific about electricity is that you cannot store it. You can store it for your smartphone, but for such volumes, it's not possible. But then it could be a problem to have a business going around, because let's say we are Solvay, we have a consumer that we want to supply on the right, and we don't buy any electricity for them. So it's going to create an imbalance, and it could have really bad consequences. And so we are Solvay, but maybe everybody is doing so, and it could be a mess. That's why the system operators, they need to share this balancing responsibility with the business. That's why on the business side, we have entities that are called balancing responsible party, and they will manage a sub-perimeter with producers and consumers. So Solvay, we manage this perimeter with the producers we are buying electricity from and the consumers we are supplying. And so our job is to keep this sub-perimeter balanced, and there is a mechanism to encourage us to do so. So each half an hour, the system operators, they will look at what we put in and what we take out. And if it's not balanced, all the imbalances, they will lead to financial penalties. So we want to minimize the imbalance as much as possible. So of course, to balance our portfolio, we have access to the market. But to do the right trade, we need to have a good vision of our physical flows. So the market we're going to look at are the spot market and the intraday market, meaning that we trade the day before and within the day. It's really good to do forecasting at this moment because we have a lot of insights of what is going on. You'll see there is a lot of data to process. But you have also to understand that there is a lot of volatility on these markets. For example, if tomorrow we are in winter in France, tomorrow is a really cold day. Because of the electrical heating in France, we are very thermosensitive. And the prices of electricity could be multiplied by 10 and even maybe by 20 on these markets. On the other side, if you're in summer and we're all at the beach, not consuming much, and there is a lot of sun, a lot of wind, there is a lot of electricity being produced, but nobody to consume it. So in this case, the electricity prices, they could even go negative, meaning that you will be paid to consume and you have to pay to produce. It's a crazy market, but the answer, why is it that crazy? It's because there is no storage. That's typical for electricity. So I'll talk to you about the challenges that we are facing, and now I will let Cheryl talk to you about how we tackle them.
So as Hubert mentioned, for Solvay to keep its competitiveness as an electricity player, it's important for us to have a vision of how much we put into the grid and how much we take out. And hence, what we try to do is to create a reliable and accurate forecast of the production and consumption of electricity. So for now, let's focus on the producer part. So here, we're forecasting the production of solar and wind energy. And what we're doing is providing a day-ahead forecast. So what does it mean? So if today is Thursday, what we're providing is forecast for tomorrow, Friday, for the hours of 0 to 23:30 with 30 minutes intervals. So it's a total of 48 forecast values. So how do we proceed with creating this forecast and incorporating all of this volatility within the within the day-ahead forecast? So because it's renewable energy, of course, we need to consider weather. So for example, if you're going to predict the production of solar energy, it's important for you to know irradiance. If it's for wind parks or wind energy, then you would have to consider wind speed. And aside from that, we also considered other information like the characteristics of the park. So how many turbines there are in the wind park, what's the inclination of the panels in the solar park, and also as well, is there any planned maintenance, because that would impact the production of electricity. Another thing that we considered, because this is a time series, is the historical production. So what is the history of production of each of the sites of the parks that we have? So having all of these inputs, we also need to consider that the mechanism of solar energy production is very different from the mechanism of wind energy production. So we had to create one model for solar park production and another model for wind park production. And you see the R2 score there. And with this model, we were able to get accurate and reliable forecasts. So instead of just using simple statistics, we now have a more sophisticated model that incorporates more kinds of data. And it also allows the business to have a dashboard to follow the key performance indices of our forecast, as well as visualizations to kind of have an idea of the production level of each of the site. And having this forecast helps us also in our responsibility to keep the balance in the grid. And if you combine this kind of forecast with balancing prices, then you can implement strategies so that you can control the cost of imbalance. So I've presented the model for energy production forecasting. Let's now move on to the side of the consumers. So similarly, we're also doing a day-ahead forecast. The problem now with this forecasting is that we have hundreds of customers. And each customer would consume electricity differently. Like a tertiary customer would consume electricity different from a plant that has batch processing, and again, different from a plant that has continuous processing. And aside from that, each of these portfolios or each of these customers have different thermosensibilities. So some customers are very, their consumption is very correlated with the temperature, but for some customers, there's not much correlation. So before doing the forecast for consumption, we first need to factor in these differences. That's why what we did was to first do a clustering of the sites according to their consumption pattern. And to do that, again, we considered the weather data, specifically for thermosensitivity, the characteristics of the sites. And now, instead of just considering directly the historical consumption, we also need to have a way to extract the consumption pattern, so a way to quantify the regularity of the consumption pattern of the customers. And to do that, we measured some time series complexity measures like autocorrelations and entropy. So having all of this, we were able to cluster the sites according to their consumption pattern, and we were able to incorporate that in our forecasting. So we used the same kind of inputs, including information about the date, like if it's a weekday or if there's a holiday, and also, again, the type of consumption of the customer. And having this, we were able to create just a single model that would be reliable for all customers, regardless of their consumption pattern. And this model was provided us with reliable and automated forecast that works well with all of our customers, and we only have one model to maintain. And again, we have the KPI dashboards provided to the businesses. So that works for Solvay plants, for other industrials, and also for tertiary customers. And aside from that, we can also use this forecast to predict the physical losses in the grid, because electricity is not just lost by direct consumption, but there's also physical losses. So what have we achieved using this model? So if we look at how it was before we were just using simple statistical techniques to forecast the consumption and production of energy. And we see that for some sites, we're not doing very well. Sometimes we predict that we would have a high production, but in reality, it was low. But now with this more sophisticated model incorporating different types of data, as well as not just using mathematical techniques, but also using machine learning, we were able to follow the actual trend of production, and we were much closer to the actual level of production. And it's also true for consumption. We were much closer for most of the sites with the level of consumption that they have. And this forecast enabled us to reduce our imbalance cost, and because we're reducing our imbalance cost, we're also helping keep the stability in the grid, and these tools have also helped Solvay keep its competitiveness as a power aggregator and supplier. What can we do with these models? So, a step further is to, for example, also consider the fact that system operators can decide to curtail a supplier depending on the situation on the grid. You can also incorporate data on on-site IoT devices. So if you have IoT devices in your plans for the equipments, you can estimate the actual consumption of the equipments. So your forecast would be better. You can also use this for demand response. So if you have a forecast of the consumption, of the level of consumption, and also the cost of energy, then you can kind of decide when to schedule the production of your plant to keep your cost lesser. And also, you can also consider special events, like for example, the World Cup event. It was seen that when there's a World Cup, there's a significant drop in electricity consumption because everybody is out in the bars watching the World Cup. So those are the things that you can consider to further improve what we've done. So on this note,
yeah, we wanted to acknowledge the contribution of other colleagues that worked with us on the project, and some of them are in the audience today. So thank you guys for the great job.
Thank you.
Thank you.